Well, hi, good morning, and welcome to my shop. Today is, oh my, August 1st, 2024, in case you're not sure of the year. I have before me a pretty old radio. This is a, excuse me, this one's got to be from the, well, I don't know, mid-30s, I would think. Maybe even earlier than that. This is a radio that's made by a manufacturer that's here in Canada, or was here in Canada. It's still here, but has morphed into a cable company. In fact, one of the biggest, or the biggest cable company here in Canada. So this radio was built by Rogers. Rogers, yeah, that's right. People today wouldn't realize that Rogers did different things over time, and at one point, way back when, they were building radios like this. They're also manufacturing these vacuum tubes. These ones right here I'm pointing to. Well, they may have made these ones too, but these in particular, these are very special vacuum tubes. So that's a quick look at this radio. Let's take a little bit of a closer look. So it's just a broadcast radio. The volume control here. Ooh, that's very, very stiff. And a couple of interesting things. If you look at the feet on here, it has what would look like animal feet or whatever. That's a bit of a design thing from way back when. And I noticed there's a note on the top from the owner of this radio. No power cord for Jim. Yeah, there's no power cord on this radio. There never was. This is not a radio you plug in the wall. This is early enough that there were so many people without electricity that radio manufacturers made battery operated radios for those people. So probably there's no light in here because a light would be a waste of battery power. And I don't know what else to say other than that at this point. All this wiring here is really the wires that go to the batteries. I'm not even going to pull them out unless I have to. These wires may have been sitting here for decades and decades. And I pull them out, they're all going to crack and break. I don't need to do that right now. But these are the battery connecting wires. And for a radio like this, you would have two batteries, well, two separate voltage supplies. One would be probably a 6-volt car battery, a lead acid battery, one with a fair bit of power in it, and that one you're going to use to run all the heaters in these tubes. And then the other battery, perhaps two 45-volt batteries together to give you 90 volts, and the 90 volts is enough to run these tubes, enough high voltage to run the tubes. That's a bit of a guess as to what the batteries are, but that's probably what they were. Maybe these notes will say more about it. We'll take a close look in a bit. Here's a couple wires hanging here. You probably can't really see it, but there's some weird thing up here. Now you can see it. What's this thing? See, there's a wire coming out right to here. Two wires heading back to it. I'm going to and no sign of another antenna connection. I'm going to guess this is the antenna and ground, and it's going to a transformer inside this can, and then the output is going to the grid of this tube. That's my guess on what that is. So this would be the antenna and ground connections, and really this would be going to a loop antenna, not a wire antenna, most likely. I mean, it could. You can go to a wire antenna, the other one go down into the earth. But most of these radios were run with large loop antennas for the broadcast band. It has all its tubes. We'll talk a little more about the tubes now. You can see them more clearly. These ones have a coating on the outside. You can kind of tell that there's a coating on it. And this was Rogers' innovation in vacuum tube manufacture to get away from having to put metal shields over top of tubes. The shield is this coating here. The coating is connected to a pin at the bottom, so you can ground it against the chassis or whatever you want to do with it. And you can even look on these tubes, and along the base here at some point you'll see a little tab coming up, and that's connecting essentially to this material here. I don't think these tubes are strange inside. I think the numbering is different, so it's a little tricky to replace one of these without replacing it with exactly one of these. I'm not sure of that. For the most part, I've kind of steered away from these particular radios because of the rarity of the vacuum tubes. I do have a bunch of them, but I'm not even sure of the condition of them. This one, someone's written something on it. Let's get the close-up camera going, and without taking the chassis out, let's just take a closer look at what we got here. To obtain maximum performance with this receiver, replace tubes as required with only genuine Rogers tubes. They are designed especially. No, that's not a word, is it? Especially? I thought a long time ago I learned that was not actually a word. Especially for your receiver. Okay, here's another note. Licensed by Canadian Radio Patents Limited. Only for the non-commercial reception of public radio telephone broadcasting. Patented 1916 to 32, so there's a date. Oh, I see 37 coming. Inclusive. Licensed under the Hazeltine Corporation Canadian patents issued and pending 1920 to 1937. So I think they can't write 1937 there unless it's 1937 or later. Manufactured by Rogers and Majestic Corporation in Toronto. There's the serial number. Oh, for Forest Crosley Limited. Okay. So, does this say Forest Crosley on the front? Okay, I just said that. Isn't that something? Final Inspector number 2. Oh, number 2. Usually it's number 128 or something like that, but number 2. Holy smokes, now does it? Where? So I'm looking for the name of the manufacturer on here. It's not written. Unless his name is Kilocycles, which I don't think it is. So that's a little odd. There's no writing on here. You get a good look at the coating and see it. So this is obviously finger wear here. On an old radio like this, this actually shows that the radio had some life. It's not damaged like accidental damage would be. It's all in pretty good shape. Something I did notice is these screws here, here and here. What are they there for? They don't have any matching screws here. I was a little curious what those are. There's those cool feet again. A little damaged here. But again, from 1930, let's guess it's 37. That's probably 37, 38. All the way to here. Now there's a bunch of information inside here. It's fantastic that the manufacturers would do this. So there's an explanation of the batteries there on the left. And what's this? Optional. When using storage battery, connect as shown above. Optional. What? A 2 volt. Look at it's a 2 volt battery. A air cell. What do they mean by that? They don't have the voltage written on it either. Optional. Storage battery air cell. So I think what they're trying to say is, I'm going to take a guess. The air cell is kind of a regular battery you buy from your radio store to use on your radio. But some people wanted to use a storage battery, which they had. A lot of these radios went on farms that didn't have electricity, and they use these battery-operated radios. And, farmers, they're going to have a 6-volt battery laying around. They're going to want to use it. So that's my guess. 2 volt though, a 2 volt storage battery. Why would you have a 2 volt storage battery laying around? I thought 6 volts was kind of the standard right from the start. Note, connect these two binding posts together when using a 2 volt wet battery only. Okay, yeah. Speaker cord. Here's this can that we were looking at. Here's the actual can, so we get a look at it. The wires. T1, transformer 1. Green is antenna, black is ground. Well, they're both they're both just gray. We got some adjustments there. So maybe inside this can is the tuning capacitor? It's a little far-fetched, but the tuning capacitor is obviously somewhere right around there. Oh, there it is down there. It's right there. Through the cobwebs. 3-section tuning capacitor. So I'm pretty sure this is just a transformer. T1. It's got to be a transformer. I'm more than pretty sure. What else can we discover here? So here's some of the tube numbers. 34M, 1C7, 34M again, 1H4, 1F5. Well, again, we got a big hint here that these are all 2-volt heaters. Are they really? So there's a set of tubes that start with the number 1. And these are small miniature glass tubes I'm thinking of going into radios in the 50s. Battery operated radios in the 1950s, take down to the beach with you and impress the girls with your big radio with tubes in it. Those ones, they commonly call 1-volt tubes, but it's not 1 volt. I can't remember. I can't remember if it's 1.5 or what. So we'd have to find out what's going on with the voltage of these tubes. Because this is a battery-operated radio, there's no transformation of the power. You can't transform the power. So if it's coming in at 90 volts, which it is, it's 90 volts onto the plate of these tubes. And if it's coming in at 2, it's staying 2. Here's some alignment stuff. Those are the two right in the center of the screen. The 2 IF transformers. Screw, nut. They appear to have a locking feature. 600 oscillator aligning. Oh, that's off to the side. On the deck, a little adjustment there. Read the instruction booklet. Use only heavy-duty B batteries. The B batteries are these ones. Now you know where the B plus term comes from in radios. A battery, B battery, and a C battery. That's where we get B plus from. Model 651 battery operator has been approved. It's been approved by the Canadian National Carbon Company for use with the ever-ready A600 Air Cell A battery. You think battery technology is racing ahead right now, and it is. Looks like it was something going on back then. The ever-ready A600 Air Cell A battery. It's been approved by the National Carbon Company. Oh, carbon. Well, I guess they use carbon in batteries. Hey, nothing ever changes. Okay, I think that's probably it for the information we're going to get out of this. I may take a peek at the speaker here. It's got a great big coil in the back. I'm pretty sure this big can is a coil. And so that would mean in the power supply, this coil is used as part. Well, there's no power supply. There's no filter. There's no AC to DC thing going on here. So if this is an electromagnet, they're just running some power through it somehow. I'm pretty sure it's an electromagnet. And we can look at the actual makers of these. Rogers, General Electric, Radiotron. Huh. A 1H4 made in Canada. That's obviously another Rogers tube. Come on, camera. Won't focus. Anyway, so are these ones replacements? They are not coated. Not sure. Can we look down? Oh, that looks like a pretty typical IF transformer cans there. What's way back here? Spider webs. Nothing much more. Okay, so I'm trying to look at as much as I can before I do anything here. I'm trying to decide if I am going to do anything here. So I have started up these old radios with battery power supply. I do have the power supplies to do it. Well, I'm going to stop and as usual. Whoop, I'm sorry, I'm standing right in front of the camera here. Oh, I hope I wasn't doing... No, I was using the other camera. Oh my gosh, for a minute there I thought you'd been looking at my shoulder for the last 15 minutes. Okay. Yeah, I'm going to go drink some coffee and think about this. No use going any further with it if I don't have any intention of going a lot further with it. There's no magic in taking this out and looking at it and putting it back. Chances are this guy is all original underneath here. I see it has a bottom plate too. Yeah, I gotta think about it. Okay, that's what I'm gonna do. I'm gonna go think about it. I've been in here for a few minutes just staring at this thing, trying to decide what I want to do with it. Maybe something I can try. I can try powering it up. I can do it very carefully. I have the appropriate power supplies to do it. There's information in here. There's probably information on the internet on this radio too. Oh boy, oh boy, oh boy, oh boy. 2-volt heaters, maybe. Why don't we look at this up? 1H4. Let's see if we've got this in my tube manual here. 1H4. 2 volts is a little bit difficult to do here in my shop. I don't know if this is going to have it in it. So it has the, if I knew the alphabet, we'd be better off here. 1L6, these are all the little glass tubes. 1H4, medium triode. Glass octal type used as a detector or voltage amplifier in a battery operated receiver. This type may be supplied with pin number 1 omitted. Tube requires octal socket. Filament volts 2 volts DC. Amperes 0.06, 60 milliamps. So it's a low draw. Most tubes are drawing a couple hundred milliamps through the heater. This one's just a low draw because it's a battery operated radio. Typical operation, plate volts 180 max. Of course, in this radio it's going to be 90 max because that's the most that's there. Plate resistance, transconductance, blah blah. For grid bias detection, plate volts up to 180 max may be used and the grid bias adjusted. So the zero signal plate milliamps is about 0.2. This is the discontinued type, so it doesn't mention Rogers too. Well, there's nothing to it. It's just a triode. There's nothing to it. 2 volts. 2 volts on the heater. I wonder what kind of battery was producing 2 volts. That's kind of funny in itself. 2 volts. Wow. Yeah, think about this some more. Okay, so Radio Museum has this information for the radio here, and it's pretty good. It's a pretty good sheet. There's another page with the parts on it. It certainly looks like the right radio. I don't think there's any doubt of that. This is showing the battery connections here. A layout diagram. It looks very similar to the one in the back of the radio. I think it's identical, except they have this piece. It's not identical. Very similar, but not identical. And they've laid out the coils. The coils are very, very specific component to each radio. In my own imagination, I think a lot of the engineering goes into these coils here. So what am I looking for here? I'm not so sure. This looks like a permanent magnet up here. Is that what they're showing? Could be, because they don't show any wires coming up to it. Now they might show the coil just somewhere else entirely. I don't think so. Yeah, I think this is a permanent magnet here. That would be very unusual in a radio of this age. Maybe less unusual in a battery-operated radio, since there was not many options to turn this into an electromagnet running on batteries. That doesn't sound so good to me. Battery switch on volume control. So the switch is actually a two-pole, two separate switches, if you like. One for switching the batteries and one for switching the high voltage. In some of these radios, the high voltage was not ever switched off, because unless the tubes are heated, unless the tube heaters are on, there's no conduction. It's just wires to an open circuit from the battery. So in some cases they did not switch the high voltage off. Kind of unusual how they're showing this. What are they showing here? This looks like a this looks like a push-pull arrangement for the output with a single tube. Output tube 19. That's pretty curious. I've never seen that, I don't think. In every other case, I've always seen two tubes here driving the push-pull output. Or am I having a senior's moment? Output tube number 19. Well, I'll take a look at that in my tube book. Well, we got lots of information here. We've even got the alignment information written up here. Always use an output meter or other visual indicator. Don't trust your ears. What's this information up here? Just, I don't know, it's alignment information. Maybe it's the same as this. Voice coil DC resistance. Yeah. Oh, here's some more stuff to read. Shorting link across R14 is to be used only when using a 2-volt storage battery for filament supply. Values of resistance in circuit do not permit of accurate voltage check. Use plate current as indication of presence of correct grid. So what's happening here is we're back in 1937, and voltmeters were not. Maybe there were some electronic voltmeters around, but mostly no. They were meters that just used a little bit of power from the circuit they were testing to drive the pointer. And these are clunky meters, old meters, and the amount of power they drew was significant for some circuits. And that's what they're saying here. Values of resistance in the circuit do not permit of accurate voltage check. In other words, the resistances in the circuit are too high. So we hook up the meter, draw a bit of current, voltage drops occur in these resistances, and things go cockeyed. Use plate current. Sure, yeah. That's not easy to do either. Plate current as an indication of presence of correct grid and plate voltage. Voltage readings are between points shown and chassis ground and chassis, unless otherwise indicated. And there's a little tiny note here. Can we read that one too? How come these are all written? This is a pasted in. This is a pasted in piece from somewhere else. Speaker leads. Connect these two binding oh, I read that already because I think it appears up. Where did I read that? Oh, I think I read that on the inside of the radio cabinet. Yeah. Okay. That's about all I'm going to get out of this, I think. Let's look at the. We'll look at tube 19 in my tube book. See what it shows. And black, white. Huh. Really? Something probably red. I don't know what that is. You might be able to figure these out. Black and black. Black and black. Come on. Wait a minute. Oh, because these have plugs on the end. And you can't do it wrong. Like, I'm going to hook up a power supply. I could do it wrong. Oh, there's 345s here. There's 345s here. Inside the radio, they only show 2. They show 3 here. Well, 3's going to give you, more volume, I guess. For 90 volt operation, something. Let's see if we can just get a better look at that. For 90 volt operation, plug, something, inserted on secret, on Bocart, I don't know what that says, adapter, something supplied. So if you want to do 90 volt operation, you've got to get some kind of adapter plug. An adapter plug. Here it is over here again, I think. Here so they're just showing the batteries here going in series. Black to black to black. We got red at one end and yellow at the other. So that's what I need to know. I need to know this. I can see some of these wires really aren't going anywhere, right? They're just sort of going like that. And this must be the chassis. So for some reason they have the wires dip into the chassis. Okay, something's going on. How many of these plugs are in the back of this radio? Let's take a look. Two. That's out far enough, I think. What is this? What is all this stuff here? I used to have something tied to it, probably with a paper tag with a name on it, saying something. There's another one here. Look at this thing. This looked like it was wrapped around a post. Looks like they soldered 2 wires together here. Something's under this tape. What are they doing with that? You see the nice colors? Here's a red one. And this would be the yellow one. And the 2 in the middle are black, same wire, just going up and back out. So probably if I put power on red and yellow, put the high voltage there, we're probably doing the right thing. These might be the battery connections. The battery, be more specific, Jennifer. This might be the low voltage battery connections, the 2 volt wires. The 2 volt wires. I'm looking to see if is there more wire in here. There's quite a long wire going to the speaker, probably so you can pull the chassis way out and still stay connected to the speaker. Well, it's a bit of guesswork here, isn't it? Positive and negative. Maybe I got the high voltage sorted out as a battery thing. There is a bit of an issue over which one we pick as negative. Depends on the way the radio's wired up inside. And we know now these are the antenna connections. Okay, I'm gonna ponder this a little bit. What bad thing could happen if I power this up? I mean, not work. That's not bad. Like bad as in fire, as in explosion, as in death and destruction. I don't think anything. Certainly is a strange experience here when I stop in the shop and go for a break. I sit in front of the TV, drink some coffee, and I'm usually watching a video, often about AI or some other science thing or something like that. So I'm watching a video just now on the latest AI model that's been released by OpenAI, and I'm listening to what they're saying and whatnot, and I get up and walk in here and look at this. And it's like some kind of a shock to my brain to travel through 100 years back and forth here. 100 years of technological development. Right? This is the precursor to what OpenAI is doing. Hard to see it, but yeah. Okay, and many other people and other organizations are doing stuff with AI and the like, and it's going to impact, at some point, it's going to impact this. Yeah, somehow. I mean, I'm already using AI in my daily life. I use the, like it's Microsoft's Copilot. And, you know, you just ask it your question, you get your answer. It's fantastic. So, what a great time to be alive. It really is. Forget all that other stuff. Just look at the way human civilization is advancing. So I'm looking for breaks and problems with these wires. I don't really see any. Just these ones. Just these ones that I figure are the low voltage 2-volt battery supply. What to do here? Okay, because I can pretty well tell the red one and the white one and the other two are the black, I can put power on here fairly safely. Put the positive on the red, excuse me, negative on the black. Run the power up very slowly. I can do that with no heater current and find out if there's shorts or something stupid going on in the radio. It should be pretty much an open circuit. In fact, I can stick an ohm meter on here. That's even easier. Let's do that. Not sure how to interpret the results, but I think very high is what we would expect. Very high. So I've got this set on what, 6 megohms at the top, but we can go higher. And what we will do here, my hands off it here. Oh, this is going to be tough to make contact like that. Lead connected. Go on this red wire. So if it turns out there's a low resistance here, then that's pretty much it for me. Here, let's find out. Here we go. Better turn the set on. That would be a good idea too. Let's just reach over. There, it's on. Guessing what's happening here is you have a bad connection between the meter and the wires. And the meter connects up briefly and starts charging up the capacitors and showing a higher and higher resistance. And then the lead disconnects briefly, the capacitors discharge rapidly because they're old, and then they go back and start charging up again. See, like they would be discharging now. So it was 6 megohms before. Oh my gosh, I'm on the 6. Duh. 53, 48 megohms. That sounds pretty good to me. Playing around with my leads here a little bit. Stabilizing around 30 megohms. Well, that's encouraging. Let's try the other leads here. Okay, so there's no short circuit there. Although I guess if you put high voltage on it, maybe you're going to get a little bit of a different result. Just the ohm meter. Okay, I'm going to click on here. So this is the 2-volt circuit. And here. Shows a lot. 60, it's going to show a 0 there. So we're showing 3 ohms. It's not a 0. Let's just see. There's a 0. Oh, it's not a very good 0. What's going on here with my meter? Something funny going on. What's happening? Sure what to say about what is going on here. I expect this to be 0. I've never broken the contact yet. The numbers are flying up. Uh-oh. Okay, but it doesn't matter. Whatever's going on with this meter, don't worry about it. All indications are I can power this guy up safely. If we were to do that, I would start by powering up this circuit without any heater, without the heaters being hot. And the idea of that is we're just going to find out if you can actually put voltage into this radio. And so come back here a little bit, go up a little bit. All the way to here. This is my power supply up here. So that's a variable supply. I can control the output. This is the positive lead. Yes. Just making sure. There's no voltage in this right now. And then the negative lead go on this lighter color wire here. Possibility that the red lead is not the positive one? I can't imagine that. Okay, so the objective here is just to find out what kind of current flows when I apply voltage. So this is a current meter and a voltmeter here. And we're on standby right now. This control will elevate the voltage and cause a current to flow. That's how that's supposed to go. When I first pop this on, there tends to be a little shuddering. See any particular shuddering. Now I'm going to turn this up and keep an eye on this meter here. As we go, 100 volts, 150. That's probably high enough right there. No current flow whatsoever. The radio is switched on. There's 0 current flow. That's very good. Turn off. Turn on. Do you see it pop? Watch me again. Off. On. So the pop is a charging of some capacitors, and then it actually stops just up a wee bit, so there's a tiny current flow going. it wouldn't be worried too much unless it was way up, like, up a bit. I mean, there shouldn't be any current. Now, let me turn this off before I forget. Turn this down. Next thing is, can we supply 2 volts to this radio? And what is the polarity of this part of it? It's going to end up referring to the color of these wires. Yeah. So one's darker than the other. What can we tell by all this stuff here? Why did somebody do this? I would guess it's because they had 2 batteries and they had to extend this. So one battery, other battery. I don't know. It's a funny loop they put in it here. Then this one is, the insulation's all smashed off, but this is long enough you could have done 2 batteries with this one wire. Maybe that's what they were doing. Two batteries. How critical is it to get the positive and negative correct? I think it's critical I think it has an effect on the operation of the radio. I don't know if it's a showstopper or anything like that. How could we figure this out? How could we figure this out? These just disappear. There's no labeling on them. There's some labeling here. Let's take a look there and see if we can find some hint. White and black, plus and minus. We're going to say white and black. So white on plus, and on this one, white on plus. White on plus. Okay, I can remember that. White on plus. White on plus. Okay, so I would have to guess this is the white one here. It's definitely whiter. Right? So this is the plus. So this be the plus. I have to get another cord here. This one. Just 1 second here. Just gotta. Ooh. Okay, we'll use this great big one here. I got a great big one here. Okay. Fishing through a bunch of wires there. We're going to get the 2 volts from this supply here. It has a voltmeter on it, obviously. Get in there. Okay, now it's not hooked up to anything, so let's set it to 2. That's 2 on this meter, but let's check it with another meter. Just to be sure we're in the range. How far out could we be and not damage the radio? Not very far. Like 3 volts might be a little too much for it. So we want to get this right. How many volts? I think the battery's low in this meter. Maybe that's what's going on. Because what's with all the jump? Oh, now it's not jumping. Now it's jumping. Oh, I'm using the same test leads. It's great to be certain of things. This meter I left out in my backyard for 2 days. I forgot about it. Just sitting on the grass while we had tremendous rainstorms pour down on it. What? I just brought it in the house, shook the water out of it, and bingo, it still works. So we're going to use this guy on resistance. He says trying to remember to, not resistance, voltage. Jim, what are you doing? What are you doing now? Think about what you're doing here. Okay. Sit there. Sit there, don't confuse me. Too many leads. Jumping around. Come here, jumping around. Not jumping now. 2 volts, eh? Okay, 2 volts, here we go. That's the wrong one. That's my bench lights. Some of my bench lights. There's 2 volts. There we go. 2 volts with a touch extra. 2 volts there. Now, hook this up. Those tubes are going to draw current. I can get these out of here. Too many leads around on my bench. Hook this up and switch it on. Switch on the radio. So you need to switch off the radio, I think, first. Switch off. That's off. Okay, we think positive. Did I ever figure that out? Yes, positive on the way. Yes, I did figure that out. Yes, I did. All this bare wire everywhere. Short circuits are quite likely. Anything happen over there? So now I got to switch my meter here like this. This is now reading current. Unfortunately, it's a high current. It's 500 milliamps to the top. So, and you're having trouble seeing that anyway. The pointer's right at the bottom right now. So let's think about this. What was it like? What was it? Was it 20 milliamps going through that tube? 5 tubes, 6 tubes, however many there are. 6. So we'll be looking at 0.1 amps. I'll bet you it's something like 200 milliamps. 200 milliamps on here is going to be up about like that. That's my guess. Okay, starting, just hitting it with the voltage. Just letting her rip. Here I go. Right over. Okay, so either a couple things here. Cold heaters are going to draw a lot of current. So initially, something like that could happen. Right over. Half an amp going through there. Could there be a short circuit in here? Maybe. I don't think so. I think we're seeing a normal effect. My poor little power supply isn't really supposed to put out that much power. So it's probably limited and safe, drawing it like that. But how long is it going to draw that kind of current? We need to find that out. I could reduce the voltage a little bit. Let me look at the voltage number on here now. Okay, so 2 volts is actually reads almost 3 on here. So I'm going to reduce the voltage to about half. And we're going to read current again, and I'm going to hit the switch, and hopefully it won't go off scale this time. Hit the switch. Good show, did not go off scale. Jumping around. Why is it jumping around? Because again, we've got lead problems here or something. It's jumping all over the place. Bad connections here. Went right off. These wires can short out so easily here. Oh boy, it's a bad connection right here. Let's see if I can just make it stable enough. Anyway, I'm just gonna. Okay, that's stable. So now we're reading we may not be able to see the heaters in these tubes. They may just be so dull. I need a voltmeter and read the voltage here to be sure. Maybe I'm making a mistake here. Burning the tubes out. Burn out those tubes. Just sit there. Quick check here. Now it's just going to disturb the supply. Not really. And the voltage is Ooh, that's not good. The voltage is 0.1 volts. Okay, I need more clip leads. Clip my meter into here. So 0.1 volts indicates the tubes appear to be like a short to the meter, to the circuit. They appear to be like a short. It's possible there is a short. Volts. Really? Yeah. 0.19 volts. Yet the supply, what's the supply say now? So the supply shows a low. So if we were to try to increase the voltage to where it should be, it would be something like this. You have minus a volt now. Understand what the jumping is on here. Okay, so we're going to set this now to where I calibrated 2 volts. This should be 2 volts. 1.6. Oh, we could be looking at voltage drop or I don't know what. But that's the voltage at this point. Not quite 2. Let me put this voltmeter over here. It's now minus, I put the voltmeter over there, now it says minus 1.9. So conceivably these tubes are heated. The heaters are running in these tubes right now. And if I put high voltage on it, the radio may operate. Anybody want to put your money down now? I don't have any money with me, which is probably a good thing. Oh, I got this. I got some money here. I got some money. An American penny, of all things to have here. And 1 American penny. Okay, I'm going to bet that. I'm betting what am I betting? Okay, just for excitement, I'm betting it's going to work. I'm betting we're going to hear something. I'm betting there's no antenna connected. We need to put on an antenna here. Because oh my gosh, look what's going on here. Okay, we're going to put this on here. I'm going to have to run and turn on the... So, yeah, before I fully power this up, what's happened to the current flow over there? What happened there? I got it on volts. Man. Put it back to current. Oh, look at that. Current's way up there. Whew, right at the maximum with my supply. I was going to take a little break, but I think I'm just going to proceed here. Oh no, I have to go turn on the, let's just turn on the radio now. We'll bring up the voltage. Okay. Everybody whispering. There we go. I will tell you. The voltage is, the voltage is on standby. Here we go again. Take her. Yeah, that's right. That's 50 volts. So what are we hearing? Well, we're hearing a hum from a power supply. It could be from this one up here. Just gonna cut that back a little bit. Could be, you know, like this is a DC radio, so where's it get a hum? The only other place would be off the antenna. It's actually no, I don't think so. Well, it's making sound. That's impressive right there. I'm gonna go turn the antenna on and we'll see what happens here. I'll be right back. Well, it turns out the antenna is switched on already. So I'd like to rotate all this. Right, and all this bare wire here. I'd like to rotate so we can see the dial face, but you know, it's not practical. So I'm just going to reach around, tune this radio. Maybe I can turn this some distance here. Ooh, look out! Oh my gosh, this is really floppy stuff. A little further. Nope, nobody's short out now. Oh, look out! These are like designed to short here. You gotta break this. Put it like this. Eat them back up. Oh, now that was good. See how I connected this wire? I hope you couldn't really see it, but when I broke the heater, when I connected it, it took a moment for the radio to come back. That's the tubes heating up again. Thumbs up. We got we got about a volt on the heaters jumping around for some reason. Not 2 volts, just a volt. Okay, we're pretty close to. Let's tune this thing. This is probably the first time this radio has felt electricity in it in, I'm going to guess, 50 years. I don't know, of course. What's happening there? So the current is jumping all over the place on the heater current as I rotate this, but we have a strong current right now. Here we go. I think I'm turning it up. So there's no response from the radio at all. No response at all. And I touch some of these grit caps. I hope they're grit caps. That one seems to have an effect. So I think it's early stage, coming along. So here we're getting closer to the speaker. It has a little bit of an effect. None of these are having an effect. So interesting stuff. What would cause the hum like that? Let's disconnect the antenna. Nope. Not doing a thing. Yeah, the radio is really quite insensitive. Let's knock back the high voltage here. It's only around 40 volts. That's more and more voltage. Yeah, it just gets louder and louder. There's a hum. I wouldn't be surprised if my power supplies have hums in them. Okay, switching off. That's the high voltage disappearing. Doing the sniff test there. Turning. What happened? Where? How did it start working again? Well, that was kind of weird. I'm not sure what to make of that. So, put my power supply on the standby, and the voltage here just dropped. And then, as you heard the sound come up, I noticed this voltmeter came back up, and then went back down again. And that sound you heard, it's me clunking the microphone up there. It's not of any significance. Did I turn everything off? No, I did not. The heaters are off now. High voltage turned right off. Well, that was pretty interesting. I got to think about this, decide what I want to try to do. I could say, well, that's it for this radio. I don't think I want to go any further with it. Somebody else can get their hands on this radio. It's in near working condition or partial working condition, I would say. So this is probably quite salvageable. Somebody probably could, maybe me, go through it and bring it back to life. I just don't know if I want to do it on a radio this age. And myself, if this were my radio, I would do it. But it's not my radio, and it's a lot of work to get through it, and pretty questionable as to whether you're going to be successful. In my particular circumstance here, it's probably not wise to pursue this any further than I have, other than to clean up the box. Yeah, why don't I do that a little bit? Let's clean it up. Okay, last look at it after I just polished up the cabinet, cleaned it a little bit, and it looks a lot better. It always looks nice when it's shiny. Shiny is the key. I darkened this a little bit, but a little bit of brown paint in here, and this will just disappear completely. And it's a nice, neat break, if you like. It's not even that hard on the eye to look at. So there we go. Somebody somewhere is going to end up with this, and hopefully they're like me, and they will pursue it and try to bring this right back to life, because I think the possibility is definitely there. It could just be a dead tube that's causing it. Probably a little more than that, but fantastic anyway. So thanks a lot for watching this series. I gotta find another radio to put in here. See ya.